Hey there. So I'm going through some LeetCode problems, and I thought that this one was kind of an interesting one, and I thought it would be kind of fun to go through my thought process as I build this out. So I don't know where I'll land. I've literally just been looking at this for a couple minutes, but yeah, let's get to it and see if we come up with a solution. So this one's called trapping rainwater, and the idea is you have an array. The array spans the width of this graph here, and each item in the array has a number in it, and that number represents the height of a bar that resides at that x coordinate. We'll just consider that horizontal graph an x coordinate, and then there's some constraints down here, and they basically say that the size of the x coordinate can't exceed about 2,000 in width. And then the height can exceed about, I think that's 10,000 in height. So it can actually be taller than it is wide. And that's important because the solution that I'm kind of skewing towards would be more of like a two-dimensional array. And the wider and taller it is, obviously the bigger that array is going to be. And there could be memory and performance speed implications to that. So I think we could technically accomplish this without doing a 2D array, but that's going to make it more complicated, and this probably isn't worth it. So first we're going to try with the two-dimensional array approach. And so just looking at this, basically you toss these bars on a graph, and then you pretend that there's rain coming down, and where would that rain puddle up or pool in between the bars, and that's visualized here. So you can see the black represents the bars, the blue represents the water, and if tons of water came down, some of it would overflow and eventually fall off to the left and right, and we can assume that if it reaches the left and right, that means it's going to vanish eventually. So yeah, to me this looks like a flood fill algorithm. Basically you put some points on the screen and you expand that point to neighbors, and it acts as like a flood, which is kind of an appropriate metaphor for this water metaphor as well. And so thinking through this, one approach we could do is we could start at the bottom, and we could drop down bits of water and then try to elevate it, so we fill it up from the bottom up. And that could work, but the challenge I see there is it could take a little bit of time to implement that, or not implement it, but the algorithm could take a long time to run, because you'd have to put the drop of water there and then check all neighbors and see if it's going to fall off and hit the edge at any point. And that seems kind of slow, because you have to do that a bunch of times for every droplet of water, another edge detection basically. So what I'm thinking instead is we go from top down. So like in this example, this bar right here is the highest of all the bars. So what we'd want to do, at least what I'm thinking might work, is we draw from the edge of the screen, of both sides of the screen, until we hit something that's a solid bar. And if we hit that, that means that water from the left and right of that is going to fall off eventually. And anything on the inside of that is safe, because those bars go all the way down to the ground. And so we can just kind of visually check that assumption here. So if we were to start here at, let's say that's 3, maybe it's a little bit above this one. If you go all the way across, you can reach the edge, and so all that water is going to fall off. So that one is an empty row there. And then we'll say this is 2 right here. So if we go all the way here to the edge, empty, 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 and then it hits here, and so that's all going to fall off. Same thing from the right edge, it's all going to fall off, and then there's no interior. Either side of that is just going to fall off. And now we do that here. So I guess at 1, we go all the way over. It's going to fall off. It's going to hit here, and then anything to the right of that is a candidate for water that may pool. And we do that from the opposite side, same thing, and then anything to the left is a candidate. And so then we would fill in each of those coordinates with water, and it seems like that algorithm is valid, just kind of thinking through it here. And then same thing, the very bottom, we don't have to do anything on the right because it's already blocked off, but then on the left, we start there, and then everything that's not solid is water. So I think the algorithm will work. So first thing we want to do is we create a two-dimensional array, and we're in TypeScript here. So we'll do, let's say, call this matrix equal, and it's of type number two-dimensional array. And then we can pre-populate it, and I think I might have a way to pre-populate that easily. Let's try this. New array. I think the array constructor, you can pass in values. So it's going to be an array of arrays, and you pass in a number of items as well. So the first one, I realize now that we won't have the height value yet. So first thing we're going to want to do is find the tallest of these pillars here. And so like this one would be 3 tall. 1, 2, 3, yeah. So let's do that first. Find the tallest one so that we don't over allocate the array. We could just go full bore and go, 10,000 items, but we may as well save space while we can. Let's see. It's probably be a constant. So constant, and let's call it height equals. That's the name of our input. Let's call it something else then. It's called max, I guess. Max equals, let's see, height dot, and I can't remember if JavaScript has a max function. I feel like it probably doesn't. Let me just Google that real quick. Oh, okay, math.max, that's not really going to help us here. Could probably do like a reduce, and then it's like height dot reduce, and we pass in our function. It's going to do some stuff, and then we pass in the initial value of 0. And I forget which of these parameters are which, but I think we basically want to return the max of them of math.max. I don't remember if that's uppercase or lowercase. Just do lowercase. A and B. So that should, in theory, find the highest item. Let's see if we can console.log and see if we got that right so far. I guess we'll give that a type of number. Gotta return something. Alright, so height of 3. Yeah, there we go, we got our 3. That's looking good so far. And by the way, for this algorithm, I talked about painting the dots on the matrix, but after we paint them, then we're also going to have to count them up. Or I guess as we paint them, we could do accounting as well. So that'll be the final output, is counting just how many dots are rain filled. Alright, so let's see. We've got our max height there. And so now we can create array of width equals new array height.length. Naming is kind of funny, but basically however wide that first array is how wide this two-dimensional array will be. And then we'll fill that with other arrays, which have a height of the max value. And we'll fill those with, I guess, 0. Let's see, do we want a Boolean? I mean, because we might want to do 3 states. 1 state for empty, 1 state for solid, 1 state for water. I don't know yet, so let's just assume it's a number. Alright, so we got an array of numbers, or a matrix of numbers. I don't know what happens when we're console logging a matrix. Let's try that. Oh, that's cool. So I could actually output something kind of decent. So yeah, max height was 3 in this case. Let's see, 1, 2, 3. Yeah. Okay, and then that's why each of these subarrays is of length 3, and then the outer one looks like it has a dozen or so, and this one looks like it has about a dozen or so. So that looks right so far. Got our matrix. And now we're going to want to start from the top and left and right, go inward till we hit a blocker, and then everything inside of that will be water or solid. And then we can put that in the matrix as such. So let's do a for loop from the top. Let's say the y equals, and the top would be max minus 1, since it's a 0-based array. And then y is greater than or equal to 0, y minus minus. Same thing for x. We'll create a function since we're going to want to do this twice. So let's call this like function find solid. And we'll give it the height array. Actually, yeah, the height array and the current height, or I guess, yeah, height. But we'll have to call that y, I suppose, since that's already taken. All right, and then I'm going to give it a direction. So if we're going left to right or right to left, so let's call this direction, and that'll be a number. +1 will be from left to right, -1 right to left. All right, so then we would want to start at either 0 or height length -1. That would depend on the direction. So let's say start equals, if direction equals, I'll just say greater than 0, then the start will be 0. Actually, yeah. And then otherwise, it will be height.length -1. So the right edge or the left edge of the array. And then we'll do a for loop. And I guess this will return a number. That will be the edge offset, or maybe the index, I suppose, the x coordinate. Let's say x equals start, x plus equals direction. Oh, that should be the last thing. And then x is greater than equal to 0, and x is less than or equal to, actually less than the height.length. Depending on which direction we're going, it should be should always be constrained within that range. All right, so now we say if the number in that x coordinate is higher than the y coordinate, then that's where we stop, I think. So if, I guess we'll do the value that's stored, the height value, equals height x. We say if that value is greater than or equal to the y coordinate, maybe we'll have to account for off by 1 errors, but let's basically say that. Then we say return x, and then at the end, put a little to-do comment to evaluate that. At the end, if we didn't come across anything, then I guess we can return -1. Probably just return whatever x was last, but that's stored in that array there. I must be move that assignment out a level. Then yeah, it might be like off by 1 again. So let's just see that, or null. I guess since we're using TypeScript, we'd have to change that. So I'm just going to do -1. Since that's an invalid value, it should be easy to check for. All right, let's see. So let's say if this is, let's use 3 as an example here, and the height is set to let's say 0, 1, 2, and then 3 would clear it. So it should say if the value is greater than the value -1 is greater than or equal to y. So if 3 minus 1, 2 is greater than or equal to 2, then yeah, then we've collided. I think that sounds right. Confirm that later. Right, so let's see. So let's say left equals find solid height y, and then a positive direction. So that'd be left to right, and then right to left, and that'll be negative direction. All right, so now if left is less than 0 and right is less than 0, then we have nothing to do. Just continue, because then that will have been cleared and there's just no water there to worry about. That should never happen actually, because we've set the height of this array based on the highest element, so that shouldn't happen, but let's leave it there conceptually so we understand what's happening. If we cared super about performance, we could just remove that. All right, we'll say like should never happen. There's an edge case there. What if the heights are all 0? And then it's a 2D array of size 0. I don't know if that will throw an error, but let's account for it just in case. Say like if max equals 0, then return 0, because there can't be any water that can get stored there. Yeah, let's see. Now if we did hit some edges, if one hit the edge, the other should also hit an edge, and so we can assume they're both greater than or equal to 0. So let's see. So everything in between that's what we want to loop between, and maybe write some dots in the matrix. So let's say for x equals left plus 1, because if it returned that as the edge, that means that that's a solid, and the next candidate for being not a solid would be the next one after that. X is less than or equal to, or I'll just say less than the right, because again, that one we know is an edge. And now these ones we can check, then let's do x plus plus. These ones we can check if there's actually, if it's going to collide, or if it doesn't collide, then we can draw some water. And then I guess this is interesting. We could save ourselves the matrix, I think, if we don't draw the dot, and if we just count a number at that point. And since this algorithm is pretty simple, we're not actually doing a flood fill really. We're not actually drawing a pixel and then going to its neighbor and then drawing that. Could probably avoid the matrix, but let's try that. Let's get rid of that matrix. Are we using it anywhere? I don't think we're using it yet, so let's assume we're going to use a counter. So let's do let count equals 0, and then whenever we're returning, we'll just return count. So now we can say if, well, first of all, let's get the height at that spot. It's kind of like this one here, but we'll have to, that's good. I was wanting to make sure we weren't going to use this variable name again, but we're not, so good. All right, so now if this value, basically this same check here, we could probably put that in a function. Function will collide, or is water higher than the solid that's at that point. We'll make that a Boolean, and the height array be a parameter, and then the y, I guess the x, will be a parameter. So now we can basically toss that thing in there. Don't have to repeat ourselves. Height, all right. Y in here. all right, because we have to check a certain value. Okay, so if y is that, then return x, and so we actually just want to return true or false in this case, but, well, let's return x, or number, else return -1. So in this case, we could say, what is that? Is water higher? What is it actually doing here? Start, turn the x coordinate. So get x collision. I don't really know what to call it yet, but let's just do that. And then we pass it in height, x, y, and now in this case we return it if it's greater than or equal to 0. If x is greater than or equal to 0, return x. Okay, kind of simplified that a bit, and now we can call this over here. It's kind of the same call we just did. Okay, so we didn't assign that to a value. X collision equals, alrighty. We're going to do kind of the same check here. But in this case, we're going to increment the count. So that count of water dots. And then, yeah, that makes sense. Okay. Technically, we could just fill downward, but I don't think that's going to save us any time. In this case, how we implemented this. I feel like I need to check on this more, but let's just try it out. Wrong. Return 9. Interesting. Should return 6, I think, if this first example is the same as that one, which looks like it probably is. Alright, so let's see how to troubleshoot this one. Let me just look at what I just wrote, make sure it makes sense. Get the x collision. Collision. I don't know if I'm spelling that right, but just assume we are. Oop, wrong thing. Alright, make sure I didn't introduce some typos there. Oh, I did. X. Oop. Okay, back to our same wrong answer. Let's try logging it. So we have our nice visual thing here. So let's see, y, those y's are all at 0 and 1, 0, that makes sense, that looks right. So then x, let's see our height, we got 2 of them that are tall at 7 and 8. It's kind of like right around here-ish. So it should be 0, 1, 2, 3, 4, 5. 5 should be the only tall one, I think. Maybe I've got my conditions inverted or something. What's it? Does it have a 5? Well, actually, that was it. Let's see. 0, 1, 2, 3, 4, 5. Yeah, should be 2, 4, 5. Huh? 2, 4, 5. It's like I've got it inverted because I don't see 2, 4, and 5 as any of those x's. All right. Maybe I inverted it. Let's check on that. Get x collision. Maybe we want to invert this here. That seems more correct. Let's check that. Yeah, a different wrong answer. Oh, interesting. View more. I wonder if I just check on it real quick. Value -1 greater equal y. I don't remember if there was a view more. Oh, there is. Okay. So 3, I think, is the lowest one we have. 0, 1, 0, 1, 2, 3. This one. That's weird. Maybe we should try this one. I was gonna say one row at a time, but that first row is going to return nothing in theory. We can check that. Well, these indicate that that's the case as well. So we could just try the second row maybe. So let's see, 7 and 8. Why would that be 7 and 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10's in there too. Huh. Let's log these lefts and rights. The first one looks about right. This looks like about 7. Now the second one, 3 and 10. 0, 1, 2, 3. That's right. That's 11, 10. So that looks right as well. So then it would loop from here to there. All right, let's see. Make sure that last one's right as well. Left 1, right 11. Yeah, okay. So I think this one is good so far. So something in here is a problem. Okay. Let's get rid of this since we don't really. Well, maybe we might want that again. Actually, just copy that. Alright, so we got our first collision here at a y of 1, 0, 1, so that second one, that makes sense. Left of 3, 0, 1, 2, 3, okay, right, and then x of 7. That's here, that doesn't make sense. Y collision 7. Maybe I'm mixing up x's and y's or something. Let's see. Do I use y in here? I do. X, I do. Alright. So at the x coordinate, we get the value. We're comparing that value against y. We're doing a -1. So let's see, that would be at 7. What is the? I don't think I logged the value at there. So let's try that. Would be height at x. So 3. All right. So we are comparing 3 against a y of 1. And we want to see if y is greater than that, basically. So this should be inverted. Maybe we had that right originally. Maybe not. So is y of 1 greater than or equal to 3 minus 1, 2, which is not. It should return -1. All right, let's try that. Okay, just messed up that check there. Y is greater than. Oh, maybe there's 2 checks. So maybe that's what I'm getting confused about. Yeah, one we want the collision to happen and one we don't want it to happen. So let's create a second function. I should have repeated myself in this case. I don't know what to call that. So one is we're looking for a collision and one we're looking for a gap, I guess. So the collision will be if the pillar is at least as tall as the y coordinate. So y, well, let's say the pillar is at least as tall as the y coordinate. And then the other one should probably be inverted. Let's assume that's the case for now. So then instead of get x collision, we'll do get x gap. See what's wrong here. x4, y1. 0, 1, 2, 3, 4. Maybe we got off by 1 error. Yeah, that looks like it should be the kind of the first one, but like higher. So what was it? x4, y1. Oh, yeah, that's right actually. Let's see. 0, 1, 2, 3, 4, and then y instead of 0, 1. So that looks good. And then the second one, x4. Oh, I have a second console log in there. All right. Let's actually just do one of these. I don't like having this redundancy. Alright, so x4, y1, yep, x5, x6, that's all good. Now 7, that one should return, oh interesting, x gap is -1. Oh, I'm indiscriminately logging them, okay, that makes sense. So if I check on here, that will be better. Alright, so 4, 5, 6, those first 3 there. We skip 7, we should skip 8. but we don't, because off by 1 error maybe. I don't want to think about that too hard, so I'm just going to try this. Hey, there we go. Get off by 1 error. All right, let's submit it, see if it works. Output limit exceeded. Oh, console logs. Huh. All right, let's get rid of those. Time limit exceeded. All right, didn't like something. Let's check on this. It passed, but took too long. Doesn't really give us any clues as to which one took too long. Yeah, we saved a little bit of time by not doing that matrix. Let me think about that. Just see if there's some optimizations we can do. Well, let's just try it, submit it again. Maybe we'll get lucky and it'll be a little bit faster. Oh, okay. Oh, and then here we go. That's actually good. Now it gave us one that failed specifically, which is this one. So it looks like there's a heck of a lot of data in there, and they're all very tall. So in the case of a tall one, that's interesting. So for a tall one, that could be like 2,000 wide by 10,000 tall. That could take quite a while to go over all those. How to speed that up? One thing I was just considering is that if it's the extreme case of 2,000 wide by 10,000 tall, there's fewer of them wide than there are tall. And if we optimize towards each pillar, like accessing some sort of pattern on a pillar basis, then we could cut out basically a fifth of the work. But nothing comes to mind immediately, so let's keep thinking through it. Just look at our algorithm. So this one's inconsequential. We're just going through 2,000 items, finding the biggest one, and got our matrix thing we're not doing. Let's see. Well, there might be some quick optimization. So if left is -1, then we don't have to check on right because we've already ascertained. Well, again, this should never happen. In fact, let's get rid of that so we don't have to think about that anymore. And just make sure that still runs. Okay. All right. If we sorted them based on their height, oh no, I think we could run into the collision detection first. Well, that makes sense. Think about that. So instead of going through every 2,000 in every row, we sort them by height, and we check what's the x-coordinate of one taller than the current y-coordinate. We could do like a binary search in there to get that too. Or, no, that could work. Seems kind of involved though. Since we're so close to being able to pass this, so maybe we just need to find something that slightly optimizes it rather than going through a full binary search implementation. Let's just look for some low-hanging fruit here. I mean, this stuff shouldn't really matter, but we're always returning something. Same here. Again, shouldn't matter, but let's just try stuff. Took about 2.5 seconds to run that on that one longer case. Still the same. Oh, interesting. Since we're going top down, another thing we can assume is that the water will be purely water from that top point down to whatever the height is of the current x-coordinate. And so that x-coordinate would never need to be processed again. So I wonder if that helps us at all. Like as soon as you found water, you're done. But that means that you have to process each x-coordinate, you think. So like in this case, it's like not done, not done, not done. And then only once you hit the bottom are you done, because there's these short ones. These ones are all done, so I wonder if we can skip them somehow. They would be, they might start to aggregate more like interior puddles, so you build up outward, I think. That might make sense. And if you could build outward, you would only have to keep track of, instead of going left and right to basically the opposite end, you go left and right to the minimum and maximum edges that you've already accounted for. So that would be interesting. Alright, let's try that. But then we have to like adjust this count full height, and then we can optimize this here, and maybe do, wait, which one do we want to optimize? Yeah, just this X check here. This could be 2 loops. So instead of left to right, it's left to left max and right to right min, I suppose. Something like that. Let's just put some variables down. Let's call it left edge and right edge. And we'll set left edge equal to 0 and right edge equal to height that length minus 1. or inverted. Like those are the known things we should check. So maybe we do the opposite. Okay. So then I think we need 2 loops. X is less than or equal to left edge, or the minimum of left edge and right. But left edge should always kind of change over time. And then x equals right edge. Okay. All right, so if we find something that has water or a solid, that should be checked here. And the left and right edges should adjust accordingly. All right. What do you think about that? All right, let's say left edge equals math dot min max. Let's see what is left edge. Yeah, min of left edge and the right, maybe. Or is it the left that I want to do? It's the left. Yeah. Okay. Right edge and the right. Again, there may be some off by 1 errors there, but let's just try that for now. I think. Well, we haven't set them. We'd only do that after we process this row, I think. Yeah. But up here, we could say that the left edge, let's see, where does this one go? To the left edge, and then that was and then it should have been max in this one. Let's see, wait. That should have been left edge and right, I think. Can't save. All right. I don't know if that makes sense, but let's let's give it a shot. Made some intuitive leaps there. Left edge could actually be set to right. Okay. Now the gap here should be the difference of the height at that spot and the current y coordinate. So plus equals diff, and diff, let's set up here, equals y minus height at x or something. inside the other loop. But I just want to define diff once, so I'll just do that. Alright, so diff equals y minus height of x, same thing down here. Should probably be a function, but whatever. And plus equals diff. Because basically what we're saying is once we've processed that interior and we've drawn bars of water all the way down, that water column, I guess we'll call it, then we don't want to process that interior clump again. We want to scooch outwards. So that's what these edges are for. Left edge and right edge. Yeah, let's just try that. Const declarations must be initialized. Where did I? Oh, that's not supposed to be a const. All right, doing some too fancy things here without thinking through them, so let's think through them. Okay. Time for logging. Let's do y left edge, right edge. Let's see here. Okay, the first one, left of 7, right of 7, left edge 11. Yep. Right edge 0. Makes sense. Now let's see. At 1, left of 3, 0, 1, 2, 3. Yep. Left edge of 7. Yeah, because that one's already been processed. Right edge of 7 as well. Yep. And then right of 10. That's all good. And then let's log the diff, I think would be good. Minus, right? Right edge. No, I think that actually looks right. Let's call this side instead of direction. To make sure we're hitting both those. That's interesting. X gap is greater than or equal to 0. Is that right? It'd be greater than 0? Before it worked. Let's just try it. I didn't want to do that. Let's go back to that. All right, y is 2. That should be this top one. And then it shouldn't really do any increments here, but it looks like it is. Side left. I think I should log more things here. Interesting. That first one, it's doing a left one on the right, which I might expect on the first go around, because what do you think about that? Yeah, because we haven't marked an interior yet. Let's try this. of 8. 11, 10, 9, 8. This one. Huh. Why would it be logging that? Oh, you're saying this one's returning the x coordinate. I should have it doing a y coordinate, I think, or the value. Let's see what we're. So this would say like 8 is greater than or equals 0, and then the diff is y minus the height at y. So that'd be 2 minus 2 would be 0. And why is that returning 8? So if y of 2 is greater than or equal to 2. Should be greater than, I think. Okay, a little better. All right, so right, that's actually what I was expecting. So let's see, left of 7, that should be 8. Actually, x, let's see, x is, did I log x? No. Huh. That was a left, a right direction. Yeah, so x, y is x, y. Have another console log in there? I do, okay. Basically, I should hit 1, 2, 3, 4, 5 outputs, I think, but I'm only getting 2. So x of 9, that's right. Y of 2, diff of 1 is right. That was going left to right. That should have been right to left. Alright, let's look at the right to left algorithm. It's both, really. If we first do that. Nope, didn't like that. Alright. This is right going to right edge. Right edge to right. Okay. Starts at 4. Okay. And goes to the minimum of left edge and right. 7 and 10. So 7. Oh. 4 to 7. All right. That looks right. Now this other one doesn't hit though. Oh, interesting. It starts at 10 because that's the edge there. We don't want that. That was the right edge, I think. Do we want to start at the left edge? No. What is right edge here? Our other algorithm, this started from the left. Basically want to start from where this one leaves off. So basically this. I mean, but we're going to skip past that center and go all the way to the right. This 7 here, which would be right edge. What is right edge here? 0. All right. But that's not good enough because we want to make sure we don't overlap. Min of left and right. It's kind of weird. I feel like I could have tossed some variables in there, but let's give that a shot. Hard to tell which row I'm on. The start sounds right, but the end sounds wrong. The end should be 10, I think. What is end in this case? End is right. Right is fine solid. Let's output right. Just to make sure. Should be 10. Let's try logging that. Oh, 0, 1, 2. Oh, that's right. Okay. What about 1? Okay, that's all good. So that first one I should ignore. So now the second one. Y1, that one's the interesting one. On the left side, should be 3 of them. Need to start putting little markers. Let's do that. first one, that makes sense. There's nothing to draw. The second one there is. And then it should start at 3 and end at 7. Let's see. I don't log that there, do I? What would start be? Oh, that's right, that's the first one. The second one, alright. Y1, start should be 4, end of 6. So a little off, but alright. Oh yeah, because I minus 1. So 4 to 6, 4, 5, 6, all three of those should result in one of these. A 1, but only see one of those. X5. This one. Off by 1 error? X gap. That's not right. 0, 1, 2, 3, 4. So let's see. This value be 1, 1. Y should be 1. Equal to. Okay, that one looks more right. But then there would be a diff. C0. Alright, so 3 of them. Yeah, that's good. So that was at 4, 5, 6. And oh, the diff is wrong, off by 1. How do I calculate that? Plus 1. Let's try that. Hey, let's try getting rid of some of these consoles. Got maybe one more. See what that does. Ooh, that is one ugly algorithm, but it passed, so good enough for now.